So my name is Sean T. Allen. The T is very important. If you were to Google Sean Allen without the T, you're going to find like a guy who was arrested for selling meth in North Carolina. Also, a guy who's a professional bodybuilder who looks absolutely nothing like me, and a variety of other unsavory characters. So many years ago, well, the bodybuilder's not unsavory, but the meth guy is. So many years ago, I added a T there to the name, so Sean T. Allen. I'm the author of Storm Applied. I'm a member of the Pony core team and the VP of Engineering at Wallaroo Labs. This talk is basically, it's about Pony, but I'm going to tell it from the perspective of reasons why we decided to start using it at Wallaroo Labs, which then resulted in my becoming a member of the Pony core team. So for anybody who's not familiar with Pony, the quick buzzword take on Pony. So Pony is an open source language. It's got a BSD, either 2 or 3 clause. I don't pay that much attention to the license on it. And the goals for Pony really are to be able to do things with concurrency quickly and safely. So it is a type-safe language. It has some unique type system aspects that might remind some people of Rust or something like that, which we'll get into in a little bit. It's memory safe in that there are no dangling pointers. You can't have buffer overruns in anything that you write for your Pony code. It's exception safe. That means that you cannot have uncaught exceptions in Pony, which would end up terminating your program. It's data race free. How many people know what a data race is? Okay, I like the in-between on that. Okay, so basically if you're writing concurrent or parallel, depending on how you want to look at it, basically programs that have multiple threads of execution, you can do unsafe things in it where you can read incorrect values in one thread that might be being written in another, or in general, you would end up with incorrect results from what you would expect if you thought about it from a normal single-threaded scenario. Pony's type system and runtime guarantees that there will be no data races. It is also it is deadlock free. One of the big things that happens if you are writing multi-threaded programs, I've done this more times than I can count in C, is you introduce locks in order to avoid data races, and then you end up with deadlocks where your program is no longer able to move forward. Pony is deadlock free. It is a compiled, it is ahead of time compiled language that goes down to native code using LLVM, which is quite fast, and seeing how everybody likes to do it, approaching or sometimes faster than equivalent C code for an ID there. The last thing is that it has rather easy to use CFFI. It shares the same ABI with C so that you can easily interface between C code and Pony code. You can call into C code very easily, thereby destroying all of your possibilities for memory safety, exception safety, being data race free, and being deadlock free. However, it can be very handy. But just so you know, anything you read on the Pony website, it all goes out the window the moment that you do CFI. There's a really interesting academic paper that somebody sent me recently for people attempting to prove those properties even when using languages which don't have those properties. Anyway, so this talk is the story of Pony told through the story of Wallaroo, which is what we've been building at the company where I'm at. Wallaroo, when we started building it, the idea was that we would build a high-performance distributed stream processor. If you don't know what a distributed stream processor is, in the big data space, you would think of things like Flink, Storm, et cetera, where you have large amounts of data coming in real time that you need to process, run some type of computations on, et cetera. Wallaroo was designed to have high throughput, where we could process millions of messages a second, low latency, where you'd be able to complete operations within nanoseconds or microseconds potentially, and it was designed to be resource efficient so that you could run it on relatively constrained machines if you needed to. When we started building Wallaroo, our primary target customer that we were looking at were financial institutions like banks and everything. which have a gap in terms of what they have for their systems for risk management type systems where they're trying to do real-time risk analysis. And at every bank that we went to and talked to, those systems would get killed repeatedly for budget reasons because they were considered cost centers rather than money makers. So we're like, hey, here's a really awesome place where we can fit a thing in. Unfortunately, banks move really slowly, and if you're a startup, never, ever, ever, ever have banks as your primary customer because you will go out of business. So at this point now, Wallaroo is, and this is really funny given the high throughput, low latency, our primary API now is Python, and it's geared towards folks who are doing stuff that's considerably slower, but still, it's still rather interesting. So this is a quote. I absolutely love it. It makes lots of people angry. It's from Sylvan Klebs, who's the original creator of Pony. The basic gist is that we spend a lot of time when we're talking about programming languages, talking about things like syntax or how expressive the language is, et cetera, and everything. And these are nice qualities to have. We'd like a syntax which is easy to read. We'd like for stuff to be expressive. But in the end, if the language doesn't help you solve whatever your hard problems are, you're not actually using the right tool for your particular job. So for a lot of the rest of this talk, I want to talk about why Pony was at the time that we selected to use it for Wallaroo Labs, why it was the right tool for us. And from that, hopefully you could learn why Pony might be the right tool for you. And also, I'll spend a lot of time telling you why Pony is not the right tool for you. So yes, why Pony? So these were 4 things that we really took into consideration when we were writing Wallaroo, is that Wallaroo is going to be highly concurrent. In order to be able to do what we wanted to do, we needed to have many different threads across many different processes operating on data as quickly as we could. We wanted predictable latency demands. That was one of the big things on it, was that a lot of the systems we were looking to displace were written running on the JVM, and they would have these wonderful JVM tail latency spikes that you get with Stop the World Garbage Collection. Everybody who we talked to wanted to get rid of those. Data safety. If you've ever written C or C++ and you haven't had data safety problems, you're awesome and you're a better programmer than me. I have a whole series of rules that I've taught myself over the years to avoid them, and I still regularly mess it up anyway. And lastly, one of the really important things for us was that batteries were not required. Like in the way that people talk about Python being, hey, look at all these batteries. We did not need a lot of batteries. We were going to, because of the requirements that we had, we were going to be writing a lot of stuff from scratch. So, highly concurrent. How does Pony help with highly concurrent? Well, there are 4 really big areas on that. First of all, who here is familiar with the actor model of computation? Oh my God, that's more people than have ever raised their hands. If you hadn't raised your hand, I would have called you out too, Tom. Okay, good. So the actor model, I'm going to cover this really quickly. If for somebody who didn't raise their hand, if it was too quick, let me know. Basically, you can think of the actor model as a concurrency model, which is sort of like managed threads. But generally, what you'd have is you have a runtime, which will schedule things called actors on them, and actors have they communicate via asynchronous messaging. So it doesn't really matter whether you're talking to something that's in the same process or you're talking to something that's in another process. Erlang is probably the most famous example of this. Scala's Akka is another particularly famous example. I'll say this, most people, when they think of what the actor model is, they think of let it crash in the Erlang model. There's nothing about the actor model itself that has anything to do with let it crash or whatnot, just the basic ideas of, okay, we have actors. Actors are responsible for managing data. Actors communicate with one another through messages, and they have mailboxes where these messages build up, and they will process them, and eventually your program will do something. So the Pony runtime, it's all built around actors and that asynchronous messaging that we talked about. And yes, both of these are really a really good way to do concurrency. It makes it much easier because what you talk about at this point is you have a model of computation now where you don't have, in fact, you don't use locks anymore, which is a big property of the deadlock-free from Pony. The deadlock-free really comes from the fact that you're doing asynchronous messaging between actors, and there's not going to be any locks that you're going to be using. There's no locks in the runtime, so you can't deadlock. Right? It's kind of simple, but it's true. If you don't want to deadlock, don't put any locks in. The moment you put a lock in, you can't really prove that you're deadlock-free. Because even if you prove it with, like, TLA plus or something, you still have to take your specification and turn it into code, and you're a human, and you're going to screw it up. Or probably anyway. So to go along with that also, the Pony runtime has an awesome work stealing scheduler. If you're somebody who likes to talk about schedulers, I know an awful lot about the Pony scheduler, and I'm happy to talk about it more after this as well. The basic idea here is that when you have actors, you need to schedule them to be running on some thread, which in the particular case of Pony, the threads are locked to cores on your machine, and the work stealing scheduler will have it where a scheduler, if it doesn't have work, will go and try and steal work from other threads in order to do that work. This can be naively done. Work stealing schedulers can add a lot of overhead. The Pony work stealing scheduler is designed really to be very efficient about that. And then the scheduler itself is designed with this concept of mechanical sympathy in mind. How many folks are familiar with that term? Oh, all right, okay, only a couple. So mechanical sympathy is this idea, and I believe the coin was termed by Martin Thompson. If I'm wrong, forgive me. But the idea is that we need, in order to have efficient programs, we need to write our code such that it is sympathetic with the machine itself. One of the big ways that Pony does this is it attempts to be cache-friendly in terms of how actors are scheduled. So, for example, if I send a message from one actor to another, the most cache-friendly thing that I could do is to send that message from the one actor to another, and then have that done on the same CPU, so that the message, which should already be in the CPU's cache line, right, will be picked up and not have to be loaded back from main memory. If all of that went over your head, I'm happy to talk afterwards about, well, the weird magical mystery that is modern CPU architectures. But yes, so big thing there is mechanical sympathy. You can learn an awful lot about it from Martin's stuff. It's pretty cool. So predictable latencies. All right. This was a big one when we were building Wallaroo, and yeah. Pony is great for this. Number one, if you want predictable latencies and you have a garbage collected language, and Pony is a garbage collected language, you can't have stop the world garbage collection. Stop the world garbage collection is going to ruin your latencies. Erlang is really, really, really good at this. If you're looking at other actor model type things, Akka is not really good at this, if you're looking at it, because it's on the JVM, and they're just fundamentally different strategies to how GC is done. Pony's garbage collection is similar to Erlang's, with the basic idea being that rather than being one large global heap that exists for an entire program, what you have is that each actor has its own little heap for the memory that it's responsible for. And you can garbage collect individual actors rather than having to stop and garbage collect your entire program, right? So with these per actor heaps, you can be continually processing. It's not like you're going to stop and do garbage collection and then continue. This was one of the most important things to us when we were building Wallaroo, because one, it was a requirement for things that we were trying to displace, and two, if you're building a clustered system, which Wallaroo is, and this includes, if you're building something like Hadoop or anything else, avoiding stop the world garbage collection is probably one of the most important things that you could do. There's a paper, I absolutely love it. There'll be links later on to it. It's called Trash Day, and it's about these folks. I think it was at UC Berkeley, I can't remember, where they vastly improved the performance of Hadoop systems by synchronizing the garbage collection for every single JVM that was in the Hadoop cluster so that they all ran at the exact same time. And this resulted in much better performance. And if you know queuing theory at all, this would intuitively makes sense, but queuing theory doesn't really intuitively make sense to anyone. So the basic idea is this: if you have worker A, which is creating work for worker B, right? If worker A experiences stop the world garbage collection, it's going to stop creating work for worker B, and now worker B is going to have nothing to do for that period of time. So we've shut them both down effectively. However, worker B hasn't gone through its garbage collection. At some point, it's going to garbage collect, and it's going to stop doing work. And worker A, if this goes on long enough, is going to have to stop doing processing that it's doing because it's going to experience some type of back pressure from worker B and worker B. Wow, that's really bad. Oh, God. That was not an intentional pun. But anyway, so yes, predictable latencies and like this where you get nice, smooth, constant work being done was really a big thing we were looking for when we were building Wallaroo. So, data safety. How many people here have written a lot of like multi-threaded C or C+ code? Oh, wow. Not many people who know this pain. Okay, so this is a great one. I learned C a long time ago, and the reason why I learned C was because it was really easy for me to get the programs to compile, which made me feel really good as a young junior programmer. And the problem was then that I had an infinite number of seg faults that kept happening, where the program would crash on me over and over and over again, and it never occurred to me that maybe there was a connection between the really easy for me who didn't know what I was doing to get it to compile, et cetera, and whatnot and that. And then even after I did that, I kept getting weird results all the time. And those weird results were really from a lack of data safety and my not really understanding what was going on with sharing data between threads and everything. So I came up with this elaborate set of rules that I would use for myself. Like, it's okay to share data between threads so long as it's immutable. This makes perfect sense. If it's immutable and nobody's writing to it, that means that the values for it will never change, and it's safe for any number of threads without worrying about it to read from it. By the same token, if a thing is mutable, for as long as it's mutable, I need to make sure that either A, only one thread is writing to it, or if I want a second thread to be able to write to it, I need to put some type of lock around it in order to make this work. And that worked out really well for me, but then I got to discover the joy of deadlocks where I wasn't actually doing the locking correctly. And what I eventually came up with was, instead of a lock, I have to give up, from one thread, I have to give up any pointer that I have to this memory that I want to mutate when I want another thread to work on it, right? It needs to be isolated so that only one thing is touching it, and I don't have any locks because I'm not smart enough to correctly do locking. That's what I learned. So, Pony has this thing called reference capabilities. This is the thing that trips up more people than anything else when they get started with Pony. It's rather hard. You could consider it somewhat analogous to the borrow checker in Rust, if you're familiar with Rust. And yes, there's no way to write a Pony program without having to deal with reference capabilities, and reference capabilities are somewhat kind of hard. They are basically those rules that I just went through that I came up with when I was first learning in the 90s. Those rules are encoded in the type system and enforced by the compiler inside of Pony. You can consider it an annotation that you put on every single variable that you create. And it can be val. This means this thing is immutable, and there's a certain set of rules for how I can share this. Ref, this thing is mutable. There can be any number of aliases to this. And no, can't share that. There is ISO, which means that, hey, this is mutable, but compiler, make sure there's only ever one alias to this at a time. I could send this from one actor to another, and that's perfectly okay, but I have to give up my reference to it such that I can no longer do anything with it. And there are a couple other reference capabilities in there, but that is the big thing on it. So the moment when I knew that we should really use Pony was early on when we were building Wallaroo. We were building some tools to go around. We did the first prototype in Python because we weren't sure whether we wanted to use Pony or not. And I was building one of the tools that was part of the test harness we were using. We were writing all those in Pony. And the compiler wouldn't let me do a thing. And I was like, why won't you let me do this, compiler? That's not very nice. And I had to talk to a couple other people on the team as well about it. And they eventually pointed out why what I was trying to do was unsafe. And I was like, this is great. I have 20-something years of experience doing this. I never would have seen that, like with a lot of other languages that I've written in before. And I know that in all likelihood, that would have taken me months or years to figure out where these occasional random bugs would come from. And that was kind of my aha moment with the with reference capabilities in the Pony type checker. If you are familiar with Rust, some people sometimes ask, why don't you have a borrow checker like Rust? I'll say that reference capabilities, when combined with asynchronous messaging, are a much easier model to try and comprehend than the borrow checker in Rust. I think if you're doing synchronous processing, in a lot of ways, the borrow checker in Rust is easier to think about, but you're going for the same end goal. It's just a difference in way that you want to go about doing it. So, batteries not required. We were trying to write a high-performance data processing system, and if we really wanted to do that and meet all of our goals for performance, efficiency, and everything else, we were going to pretty much have to write everything from scratch, from the ground up, which meant that things like libraries to do this or that didn't really matter. And the fact is that the Pony standard library is still really small. People come in all the time and are like, how do I write my web application? And we're like, well, we have an HTTP server, but it was written as an example of how to do an HTTP server. So it doesn't actually perform very well. And then from there, you could either write to like basically mostly handling all of the HTTP yourself, or you could write a web framework first in order to do that, and then you could write your application, et cetera. And there's going to be a lot of that if you're somebody who's using Pony. For us, it didn't matter. And like, but if you're someone who's like, hey, I'm hooking together 3 services and I need to speak XML over here and JSON over here, you'll be doing a lot of coding of low-level stuff if you're using Pony, so probably not the best place for you to do that. But for us, we're like, for those things where we need it, that's probably fine because the CFFI is really awesome and we can leverage an awful lot of C libraries in order to do it. We just need to make sure that, that when we use the C libraries that we're really careful about what we're doing with the memory that goes in and out to make sure that we don't blow away all of the guarantees that Pony gives us. And every single time we have a bug where at first we can't explain what it is, I think probably about half our team goes, is there a weird memory problem where something's getting overwritten in some CFFI thing we're calling? So it's there in the back of your mind, but still in the end, it's really nice to be able to drop down to the C stuff and have a wide variety of stuff that you can do there. A couple things with the C libraries, though. A lot of C libraries like to use global variables. That's not going to work. With Pony, you're just not going to be able to use those. And a lot of C libraries like to have their own thread pools, which can get a little weird if you're actually really concerned about performance. If you go back to remember what I said about the Pony scheduler, where you have, it's basically there's a scheduler thread per CPU, right? If you now have a library which you're starting up inside there, which wants to start up like, 10 threads, 20 threads, or whatever, it can start to cause problems with the scheduler threads actually getting run. And then you can have interesting emergent behavior that comes from that, where the scheduler was never really intended to have other things like banging into its threads or whatnot. So, results from all of this. Probably the biggest reason in the end that we went with Pony more than anything else, we looked at a bunch of different languages that we thought might work, was that even though it was somewhat immature at the time, the Pony runtime was going to give us a huge leg up in terms of what we were going to do. Like, for the other languages that we were looking at that could give us the performance concerns, performance stuff that we really had, we were like, we're going to have to write our own runtime that does scheduling the way that we want. We think that the actor model really is the right way to build a system like this, et cetera. And basically, as far as we considered, it was like an 18-month jumpstart for free. More than anything else, we were going for the Pony runtime and working from there. if we had done this in something like Rust, which was something we were seriously considering, you know, instead of being up here and being able to tell people later on about, hey, this cool product that we have that, you know, that we opened up the code for last September or whatever, I'd be up here going, and hey, you can probably see some code from this, you know, in another 5 to 6 months, and we'll have a product for you to show. Except I wouldn't be up here having that conversation because we never would have secured any of the funding that we got to keep building the thing. So on that, it's like that was huge. And every time I think, and there's a moment where we run into a problem with Pony, and I go, should we have picked something else? I always have to remind myself of that one. Additionally, Pony's performance, for the most part, is really, really, really awesome. We've gotten excellent performance from it. We're incredibly confident with our refactorings in a way that like we wouldn't be if we decided to go with C++, which is something that we were doing. The reference capabilities and the fact that we know that we're deadlock free, et cetera, really gives us a lot of confidence to change things in a way that I've never had that level of confidence in a multi-threaded code base before. But, you know, there is also some pain that's come from that. Everybody tells me I shouldn't end with the pain things, but hey, honesty in advertising. So Pony is pre 1.0, all right? For us at Wallaroo Labs, this hasn't really been a problem with the fact that there are regular breaking changes because we are the #1 contributor as a company to Pony at this point, and most of the breaking changes come from us, right? It's true. We are, so if you're somebody else who's trying to use Pony and you've had things break under you, I'm sorry. I was probably in some way responsible for that, but not always. We did run into compiler bugs. There are still compiler bugs in certain areas. If you write a Pony program which walks the same path as Wallaroo Labs, you're probably not going to hit any compiler bugs at this point, because we've fixed those ones. But there are some in other areas where that's a problem. Like I said, there are the breaking changes. Here's limited tooling. If you're in love with using like an IDE, like an IntelliJ or something, okay, here's what you're going to be doing. You're going to be doing your debugging in GDB or LLDB, right? A nice old-fashioned step debugger. I'm wonderfully happy with that. But there's pretty good support there. Like you can actually work with the Pony objects inside there. You have to learn a little bit of LLDB magic, but not much in order to do this. If you're somebody who came up and you were using like Emacs or Vim, and you've created a tags file before, so you can jump around in your code and everything. Hey, welcome back. All right, this is the type of tooling that we have in Pony there. One of the things that we keep trying to get somebody in the community to contribute is a Microsoft language server, so that we could have IntelliSense and everything to go along with VS Code and other stuff like Emacs and Vim have started to do that. But what happens right now is a lot of really enthusiastic people come in and go, ooh, I think I'll take that on, and then realize, wait, I'm trying to learn a language by building actually a really complicated tool for it where I need to know a lot about the compiler, and they get frustrated. So, but yeah, you get the limited tooling. And in order to get the great performance, and this is becoming less and less so, but it's still, you definitely need runtime knowledge in order to do that. We have a friendly little community that can help you with that. I can tell almost everybody what to do for that. There's a nice thing on the website that I wrote, which is like, here you go, here's all the performance things that you probably need to know about, etc., including some interesting characteristics of the garbage collector, which are, until the next revision of the garbage collector, can have performance impacts on your code. But I mean, all in all, these are things that you're probably going to get with almost any new programming language. And you have to go back to that question of, are the hard problems that Pony is trying to solve, are those the hard problems that if you have, right? Because if they are, then Pony is the right language for you. And if it's not, then unless you're just playing around as a hobbyist, it would be a really bad idea to use Pony. But if you have those problems, it could very well be a very good idea to use Pony, right? I mean, like, if you have a hard concurrency problem, minimum, and concurrency depending on like the level that you work at. Like we're really talking about multiple threads, right? I need to be able to manage multiple threads and have them work together. If you don't need a lot of existing libraries, then Pony could be the right language for you. That pretty much probably rules out anybody doing web development right now, which is, it's the land of libraries built upon libraries, built upon libraries, built upon libraries. And you have to be willing to go, I'm going to write probably most everything from scratch. There's some good high performance, like we got maps, we got persistent maps, et cetera, like wonderful data structure things, et cetera, you might have, but it's like, hey, I want a high performance JSON parser. We don't have a high performance JSON parser right now. We have a slow JSON parser, but I don't know. JSON parsing is sort of like fixed parsing. I think a couple people nodded their head when I said a couple finance things earlier who would understand it's great. Finance people really want to go fast, so of course their interchange format is incredibly slow to parse, creates tons of garbage. It's kind of like, I don't know, if you've written a web app, have you ever noticed how much time you spend collecting garbage that came from parsing JSON? It's like that, except you're supposed to be you're in a system that's supposed to respond in 1 microsecond. So, yeah, anyway. I told myself I wouldn't do that. Right, so takeaways from this. Pony has a powerful data race-free, concurrency-aware type system, right? That it can help you solve hard concurrency problems if you have them. You might be able to use Pony in production right now, right? If you have those problems, I would recommend popping into the Pony community and checking about those things if you have those types of problems. And if you don't, then you're not a hobbyist, then come back and see us maybe in a couple years and we'll probably be further along. We're further along now than the 2 years ago where we were when I first joined as a core team member. So I actually went through and mentioned a lot of things during this talk. They're all here in this GitHub repo. I've done some version of this talk a couple times. The links to the videos from those where I may have said slightly different things, including the one which was aimed at fintech people, are in there. There's the slides for this talk are in there as well. They'll also be going up on the O'Reilly OSCON website. But yeah, everything is in there. Hopefully that's relatively easy to remember and put in for GitHub. And I'm happy to take questions either now or afterwards. And hi, Eric. How are you doing? Also, what is your name? Because you look really familiar. Yes, you.
My name's Trevor.
Trevor.
Sorry, you don't look familiar at all.
You sure? You really look familiar.
Fantastic.
Oh, awesome.
Oh, cool. Thank you.
Oh, good. Yeah, I'm going to really forget to repeat questions, so
Okay.
Stop me.
Wow, I've never done this before.
Boom!
Yeah, this is first for me too. I'm really excited about all the type safety and the data sharing and things like that. But you brought up Erlang early on,
Yes.
which is established and from what I understand is really good at the actor model stuff. So
Yes.
what led to you choosing? Did you consider Erlang? And if you did, what was it that it didn't do that adopting a pre-production language? But I mean, a lot of these features are super exciting. So like.
So I want to preface this with I love Erlang. I think Erlang is a great language. It's
Absolutely.
one of my favorite languages. So I have a lot of friends who worked at Basho. And one of the things that we did was we talked to them, and I have a number of other friends in the Erlang community who came from that. And we sat down and had conversations with them about, realistically, this is the type of system that we're trying to build. Do you think Erlang is a good tool for this? And in certain areas, they were like, Erlang is a very good tool for this. The thing more than anything else that really worried them was the plugging in user computations. And what that would, so like part of the thing with Wallaroo is that we give you an API so that you can write, it's a framework, and you write computations that will be run at different points in time on the data. And they had serious concerns about what would happen with the Erlang scheduler with that, particularly because we wanted to support languages other than Erlang, which basically meant going through something like the NIF system in order to do it. And the NIF stuff is fraught with a lot of problems with Erlang. And between that and some concerns they had about like the actual amount of throughput that we could push through for a given Erlang node, they more or less were like, we don't think you should do this. And given that they had large amounts of experience with it, we were like, well, we were kind of sad at first. We were all kind of like, ooh, that would be cool. And then we moved on to other stuff.
All right. Well, thank you very much.
I mean,
That definitely answered my question.
yeah, awesome.
Any other questions?
Yes, Mike.
Is there a roadmap for 1.0 or anything?
So people always ask about roadmaps. Pony is a 100% community and volunteer-driven thing. So I could tell you about things which we, as members of the core team, are really interested in seeing happen, but there's not a roadmap per se. I think it's more like these are things that we really want to see addressed before we would ever put a 1.0 stamp on it. There's some inefficiencies in the garbage collector and one garbage collector bug, which requires a rewrite of part of the garbage collection process, which we would definitely want to address. There's an awful lot in terms of documentation and tooling that we would consider important to becoming 1.0. And there's a few other things in terms of features where there's, Pony is object-oriented, but there's no inheritance, for example. It has both structural subtyping like Go and nominal subtyping where you have to actually name what it is. And when we've really started to use Pony a lot in the real world, we found that there are some ergonomics problems in terms of that are unrelated to the type system for actually composing code together. There's some work around that where we've really started to have a lot of conversations. We would want to address that. And there are a few others, but there's not a roadmap per se. It's these are things that we really want to address. One of the biggest ones is Pony has this common pattern that you follow is there's an actor which is created that does something like manage a TCP socket for you. And you, as the user, can specialize it with code that gets run when a connection is opened, a connection is closed, et cetera. And there's a serious ergonomics problem right now, which has led us at Wallaroo Labs to rewriting our own TCP ones because there's no way to communicate with the user code inside. And so it's mostly issues like that that really need to be addressed.
I think we have time for one more question.
Don't worry, Sean, this one's a softball, I hope. So one of the things that I really like about Akka is that while you have the actor model, they also built a really nice streaming API on top of that. Are there any plans, or have you thought about, I know in the Wallaroo case, you kind of punted that out to the Python API. Are there any plans, or sort of, are there any plans to do something similar to make a more approachable API for dealing with streaming?
Wallaroo has a Pony API as well. We just don't advertise it because, well, the market is right for that right now. There's also really early on somebody told Sylvan, hey, you guys need to do reactive streams. So they did a reactive streams implementation, which still exists, and somebody recently brought it up to date with the latest breaking compiler changes. There are certainly things like that which could be interesting. The big thing behind a lot of those is that one of the really big concerns with Pony is performance and everything, and an awful lot of those types of abstractions take you further away from the runtime and end up potentially in situations where you're not going to get as good a performance as you would. So it's one of those things where if somebody builds it, we'll happily help them support it, like in the Pony community, but it's not something that there's a lot of people in the Pony community going, oh, blah, 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 et cetera. Most folks in the Pony community are like, oh, if I'm going to do streaming, I'll use the Wallaroo Pony API. Cool. One thing, I normally have really cool Pony stickers, but I didn't have any money to buy new ones for them, et cetera. But if you like stickers with cute little animals on it, the Wallaroo Labs the Wallaroo Labs mascot is ridiculously cute. It's the sort of thing that when we get to Series A, we're going to have plushies made from it. That was my #1 goal for naming the company. So come see me, and I'll happily give you the really awesome, cute sticker, which doesn't have our name on it anywhere either, so you'll have to tell people what it is. All right, thanks.